Okay, I hope you can see my screen here. Um, so, hello everyone. I hope you all are safe and doing well. And to all the Indians who have joined today, a very happy Independence Day. I'm Nikhil Kashyap, a machine learning engineer. I have experience building various statistical and deep learning models for various businesses. I'll be Gandalf the Grey of today's webinar and guiding through the Middle Earth. And welcome to the webinar. In today's webinar, we'll be solving one of the popular beginner level Kaggle problems, New York City taxi fare prediction. So, coming to the problem statement, it says you're tasked with predicting the fare amount for a taxi ride in New York City given the pickup and drop off locations, blah, 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 RMSE of $8 to $8, and your challenge is to do better than this using machine learning techniques. So, what does this mean, right? Let's suppose you're in Manhattan, New York, and you have bought the tickets to US Open Finals that's happening next month, right, on September 13th. And you wake up, it's a beautiful weather, it's a beautiful day, and you're excited, and you call a taxi, and you say, take me to Billie Jean King National Tennis Center. Upon reaching the destination, you pay some fair amount to the taxi driver, right? So that's what the problem statement is asking. So what we have here is a pickup location that is Manhattan and a drop-off location that is Billie Jean King National Tennis Center. So what the problem statement is saying is, given pickup and drop-off locations, can you predict the fare amount? All right. It says through basic estimation, the RMSE is $5 to $8. RMSE is root mean square error. If you don't know what it is, just to give you an intuition, let's say the fare amount was $20, all right, and you predicted with some error rate between like +5 -5 to +8 -8 of that fare amount. If you think about it, that's not a really good prediction per se. So you can download the data using this particular link on Kaggle. It's available to everyone. You can, if you don't have an account, you can create an account and download it. So after downloading the data set, you get two important files. That are there train.csv and test.csv. In train.csv, you have all the input features, and along with the target variable which we need to predict. That will be the fare amount, and it's about 55 million rows of data. That's a huge data. And in the test.csv, you have input features, and it has about 10K rows. And in test.csv, you don't have the fare amount column because that's what you need to predict. And coming to the data fields inside the file, so there is key. Key is the unique ID. It's of string data type, and you have pickup date time. So that's the timestamp. It's the value indicating when the taxi ride started. And you have pickup latitude and longitudes. Those are the coordinates of where the taxi ride started. And of course, you have a drop of latitude and a drop of longitude. Those are the coordinates where the taxi ride ended. And all these are and have passenger count. So it indicates the number of passenger in the taxi ride. And we have the our target variable, the fare amount, that's of float data type. It's the dollar amount of the cost of the taxi ride. And as we know, it's present in the training set, and we need to predict it for the test set. So let's dive into the coding part of it. Right. So coming to this, this is what I'm using here is Google Colab, and Google Colab is the Jupyter Notebook on cloud. If you don't know, to anyone who's new to programming or data science, if you don't know what Jupyter Notebook is, it's like an IDE, an editor where you run your code. I have already downloaded the data set because it takes some time. So let's dive into it and start by reading the data set. So what I say is, I say import pandas as PD, all right? So what does this pandas do is, pandas is a Python library used to manipulate and analyze the data set. To give you an understanding, again, for anyone who is new to programming or data science, loosely speaking, you can think about pandas as Microsoft Excel. Like how you can sum the values of a column or remove empty rows in Excel, you can do the same operations with pandas. But you need to remember, pandas is not Excel or vice versa. So in a so next we'll start with directly reading the data set. I'll come to what percentage time is here. So I'll say PD indicating that pandas PD here, and I'll say read CSV. All right. We saw that we have in a train.csv here. So it's a CSV file. So I say read CSV. If it was Excel, I'll say read Excel. If it was HTML, I'll say read HTML. So you get the point, right? It's all syntax. It's pretty intuitive. So it's a CSV file. I'll say pd.read CSV, and the pandas will ask now which file. So I'll say train.csv. As I told you before, it has 55 million rows, and that's a lot of read and process within on the limited time we have here. So what I'll do is I'll read only 5 million rows of data. And yes, right. I'll read the 5 million rows of data. So for faster computation and for the faster processing. So once you have this here, you can what you do is you assign it to a variable. You can name your variable whatever you want. You can name it as taxi or whatever you want. You can name what the variable. I'll say it as df as in data frame. So I'll run this. Now coming to what percentage time is here. It's a magic command. It returns two values, CPU time and wall time. CPU time measures the time during which the process is working on a certain task. The processor is working on a certain task. The wall time measures the total time for the process to complete. If you look at it here, for this particular task, the CPU was involved in this particular task for busy with this particular task for 10.8 seconds, and the total time required to process this whole thing was 16 seconds. So that's what it means. So once we have this, so what I'll say is we'll look how the data set looks like, right? So I'll say df.head. Df is this the variable what you have assigned to. So this is how the when you say df.head, it gives you the first 5 rows of the data set, and if you want the 10 rows, so I'll say df.head of 10, so it will print the 10. If you want the last rows of the data set, you can just say df.tail. So here we'll just go with df.head, and we have all the columns here, what we discussed about earlier, and everything is right here. So to get a little more understanding about that data set, you can say df.info. So here .info method, what it does is it prints a concise summary of the data frame. We can see the columns and their corresponding data types here. If you look into it, pickup date time is of object data type. The thing is, if you want to perform any operations on pickup date time, if it's an object data type, it won't happen. So that's why what we do is we convert the pickup date time to a datetime object to perform operations on top of it. What we'll do is, so we need pickup date time, right? So I'll say pd.to date time. So what does it say is I'm telling the pandas to convert whatever I'll send in here to datetime object. So what I need to send here is, pickup date time, right? Now, if I run this, we'll get an error. So I need to specify a format. I'll come to this in a while. So what I'll do is %t and %h, %m, right? So what does this mean is, if you look at it here, we have pickup datetime in the format of y, year, month, date, or minute, seconds, and UTC. That's what I'm specifying it here. So so if you just send the series into the data frames, the pandas dot to datetime method saying, convert this particular column to datetime. So it will ask which format it is in, so that it already knows to what to look for. If it was in any other format, you need to specify other format here. So that's how it works here. So once we have this here, so we can, if everything is in place, we can just run this. Right? Oh yeah. Pickup datetime was object here. Now pickup datetime is for datetime object. So everything is fine now. So what we'll do is, to get a little more understanding depth inside the data frame, I'll say df.describe. What df.describe does is it returns the summary of the statistics of the data frame provided. All right, so it has count, mean, standard deviation, minimum, and maximum, and everything. So if you spend a little time here, you will see the following things. Fair amount, minimum fair amount is negative, so that doesn't make sense, right? So minimum fair amount being negative doesn't make sense. So the next thing what you'll notice is the minimum and maximum of the pickup longitude and latitude are way out of bounds, and it still doesn't make sense. So what we'll do is fix minimum and maximum, latitude and longitude. All right. And the other thing what you'll notice here is the passenger count is 0. The passenger count cannot be 0, right? So what we'll do is we'll remove passenger count 0. We'll fix these three things here. So before getting into it, so we said minimum and maximum of latitude and longitude doesn't look fine, but we don't know what the latitude and longitude of the New York City is. So what Google is your best friend. So we'll say ask Google. So it says latitude is 40. It's around 41. So say latitude is around 41, and longitude is around minus 74, right? So we have it here. The minimum. We have the correct coordinates of the New York City. So what I'll do here is I'll say df.log. So to understand what .log is, the .log allows you to access a group of rows or columns by labels. All right. If you want to access it by index, so you can say .ilog. All right. So what I'll do is df.log, df of dot between. So what I'll do here is we know that the latitude is around 41, but we'll give some padding to it. You can say plus or minus 2. So I'll say give me some 40 to 42. All right. Copy paste it, and we have pickup longitude. So pickup longitude, the longitude should be somewhere. Again, you can add padding to it. I'll say padding between 70, 5 to minus 72. So now the same thing, what I need to do is I need to do it for the drop off also. So I'll just copy paste it, and right. So now what we are saying here is, for the pickup latitude, just retain the values between 40 to 42, and pickup longitude, just retain the values between whatever you have specified. These are pretty much self-explanatory, right? So what other thing? So yeah, Now the other thing is the minimum fare amount. We said it's negative, but we know that there will be some minimum fare amount for the taxi rides, right? So what I'll say is NYC minimum taxi fare. It says it's $2.5. So I'll just take that and um, I'll say df.log df of fare amount is greater than 2.5, right? So, and similarly for we said we'll remove the passenger count, which is 0. So that's what we'll do here. Passenger count greater than 0. So when we run this, we can see here, if it's done the job or not. Yeah, so now the minimum fare amount is $2.5, and it looks fine. It is minus, if you just convert it, it is minus 72.0632. And the passenger count, minimum passenger count now is 1. So now everything looks in place, right? So the other thing what we can do is we can check for the missing values. So so I'll say, what if I run this? df dot is null, so it will give me the Boolean values for each and every row. Now I can sit and see which, if it is false, then it's not null. If it is true, then it's null. So I can sit and go through everything to see if it is false or true. So what I'll do is I'll say any. So this gives me again the Boolean. If there were any null values, it would have thrown a Boolean value of true. But just to get a count of it, so I'll just say dot sum, and if there were any, it would have given me the number of null values. Now we don't have any null values, so that's good for us, right? So what we'll do is the thing we'll get into some analyzing the data. Now we have cleaned the data set. So what we'll do is we'll start by just make EDA, and we'll start by importing the required visualization package, that is a matplotlib, right? So the matplotlib is one of the popular visualization package in Python. So after importing it, what I will do is we can start by visualizing our target variable, that is fare amount. We'll see how the fare amount looks like, right? So I'll say is this histogram and give me the fare amount, right? And let's put some color to it. Okay. So if you look at it, it doesn't make any sense at the first glance, right? It's a one sad, lonely graph. So what we'll do is let's give him 1,000 friends, right? So yeah, it still doesn't make any sense. So what we do is add the X label and a Y label indicating what they are, and we'll see how it looks. So to do it, so I'll say X amount, and the Y axis is on the count. Okay. Yeah. Okay. So it says it's a fair amount and it's count here. Again, if you show this graph to someone, they would know what it is, right? It's if you just go and show it to someone, they would look at it and say, this is one stupid graph, right? So I'll just name it one stupid graph. I'll tell you why. So I'll just look at, I'll take the same code and I'll show you how to, add some style to it so that it makes sense, right? When you look at the graph, the first thing is it should tell a story, right? So what I'll do is, if you look at it here, all this the limiters on X is just nothing. There is no graph there. So what I'll do is I'll add X-axis limiter. I'll say show me from 0 to 100. Right. So once you have this, so this looks much cleaner, and this makes sense. And again, all these space here in the notebook are just wasted. So we'll just, what we'll do is we'll like zoom in the graph. All right. So what we'll do is fig size. All right. It's a figure, and size is equal to all right. So now it looks a lot better. Again, but it's still too plain. Let's add some style to it. To what you can do is to know what are the styles the matplotlib offers to look at it. Let's say t.style. So this shows all the available. So there are a lot of available style you can add to the graph, and you can pick any of these, and I'll say you can pick any if you want. So I'll say plt dot style use. All right, C1 target. So if you run this, right now it looks a lot better than what this looks, right? And this is not one step. It is histogram of fair amount. Right? Yeah. So now if you are presenting a notebook to the client, or if you are presenting it to your boss, or if you or even if you 2 months, once you look at it, you'll make out what it's saying, right? But if you look at it here, it's one side graph. It doesn't tell you a story, but look at this here. It tells you a story. It says what x-axis is, what y-axis is. It adds some style to it, and there is a title, right? Why I'm saying this is because I've seen many people who are new to data science coming up with these kind of graphs. During some client meetings, and this doesn't sell. All right. So if you look at it, this is 4 lines of code, and this is 7 lines of code, and just adding 3 more lines makes a huge difference in how the graph looks. And that's why presentation, especially in Jupyter notebooks, is very important. And what we can do next is, we know the other variable which affects the fare is the passenger count. So what I'll do is I'll say passenger count. All right. Dot value counts. What this gives me is the frequency of the categorical variable. So for the one passenger, this the count is this much. For 2 passengers, the count is this much out of all the 5 million rows of data. So that's what it's saying. And if you look at it, look at here, so there are some outliers, right? We'll remove it in a while. So if you have to plot it, so you just say plot that, right? Yes, now it's plotted, and the now what we'll do is we'll add some title, say histogram of passenger count, and we'll add X label. So X label is the passenger count, right? And we'll add Y label, and Y label is, let's say, frequency. Okay. Yeah. Now you can. Yeah. Now what you can do is you can remove all these values because 208 passengers. Come on, in the taxi. That doesn't make sense. So we'll just remove everything above 6. So what you will do is log f of passenger count. Um, right. So just to double check, so what I'll do is, right. So all the values have been dropped. So we have a much cleaner data set. So now you looked into how you'll uh, visualize the a fair amount. How will you visualize the passenger, which affects the fair amount? Now, what I want you guys to do is tell me what other factors affect the fair amount. You can just drop it in the chat box. Oh, of course, distance. Okay, yeah, just distance and time, and yeah, the number of passengers. Oh, we just visualized number of passengers. So uh, you know, so just that's it. Distance and time. Oh, oh well, okay, traffic. You can look into the traffic, but uh, yeah, of course, I'll just take them. Distance. Uh, what's it? A time of ride. Okay, ride, traffic. Okay, I'll factor in number of passengers also. Okay. Um, so what is right? Pickup and drop off locations also matter, right? So what we do is now we will um, because whatever from the whatever data we have, we can't factor in the traffic, all right? But we can do the rest of the things due to the time constraint. So I'll pick the distance and pick up and drop off locations. So with the pickup and drop off locations, show you um, with another visualization package which is called Folium. What we will do here is, and this is, we'll draw a map. All right, we'll draw a map and we'll plot the pickup and drop off latitudes on top of it. All right. So what I'll do is folium dot map equals. So what's the location? Yeah. And minus, okay. So what I'm saying here is, I'm telling the Folium to draw a map of this, you know, giving the latitude and longitude. So for this coordinates, draw me a map. So, and what we can do is zoom t equals, right? Okay. Passing it as a string. And for everyone, who's again new to programming, uh, most of the programming is like this. You don't randomly type three keys and you hack into the some satellite, right? So yeah, now we have drawn a map. This is the NYC map. We have asked the Folium to do it, and it has done. It has done a really good job. So what we'll do is we'll loop through uh, you know uh, through 100. For now, let's just take 100 pickup and drop off locations. So we'll just take the first 100 and say Folium, give me a circle marker, all right, on location. Pick up, right? Yeah, latitude of I'll explain it to you guys in a minute. I'll say, then what do you have? Pick up longitude. Okay. I think I need to. And what I'll say is, we'll just green. You can add any color you want, and I'll say add to a variable that is NYC. All right. Now, if you look at it, yeah. So you can see, all the pickup latitude, the pickup coordinates being marked using the circle marker here. So what I was saying here is, I was asking the Folium to draw circle markers for the pickup latitude of I, that is the looping whatever we are doing here, and the pickup longitude. So together they make the pickup coordinates, right? So that's what I'm saying here, and this adding some color to it, and now we have a beautiful map displayed. So we can do the same thing for the drop off also, right? So what we'll do is we'll take the same thing and drop off. We'll change the color. We'll just green, right? Yeah. Now, all the green represents the pickup and all the red represents the drop off. You can do it for the whole data set, and you can, use any other kind of marker. You can reduce the radius of the circle marker. You can do many things on top of that. Right now, for you to give you an idea, so this is how you can use Folium to visualize the data. So the next thing is, what you can do is we'll do we'll do something called feature engineering. All right. So what does this feature engineering do? So it's a process of what you do is you use your domain knowledge. It's a process of using your domain knowledge to extract the features from raw data. So what we'll do is, if you remember, we converted the pickup date time from object to date time. So that's exactly because for this particular step. So what we'll do is pick up date time, right? And yeah, so what we are doing here is we're saying, take the pickup date time column and extract the year from that pickup date time and paste it into df of year. That's the new column what we'll be creating. All right. So you can do the same thing for month, right? Month, and can do the same thing for day. And you can do you can get a, if you have the date, then you can certainly get what weekday is it, right? It's a Sunday, Monday, or whatever it is. And what we can do is we can extract the hour also. So what we'll be doing here. So if you look at it here, yeah. So all these values have been stripped and extracted to a new column called year, month, day, week, day, and hour, right? So everything is in place here. Um, so the next thing what we can do is, so somebody told distance, right? We had distance here. Yeah. Okay. So that is what we do. Okay. What we'll do next is we'll calculate the distance between the two locations. All right. So to calculate, we know that Earth is not flat, right? So if it was flat, then we could have used Cartesian coordinates to calculate between the Cartesian distance to calculate between 2 points. But Earth has a curvature. So what we'll use is something called HAVERSINE distance. So to give you an understanding, so the HAVERSINE distance is the distance, the angular distance between 2 points on the surface of a sphere. The formula for particularly this problem, is in the distance between pickup and drop off is equal to 2 arcsine of square root of sine square. The square root goes on for the rest of the formula, and the pickup latitude minus drop off latitude by 2 plus and the rest of the equation. As the Earth is nearly spherical, the Haversine formula provides a good approximation of the distance between 2 points of the Earth's surface with less than 1% error on average. All right, it just gives less than 1% error on average. So that's a good formula to use. So what we'll do is we'll ask. That's a complex equation. So what we'll do is we'll ask good people on internet for help. So what I'll do is Stack Overflow. Most of the programming is you'll be Stack Overflowing a lot of things. So I'll take this and use it in my notebook here. So what we need to pass here is you need to pass the pick up longitude, pick up latitude, pick up drop off longitude and drop off latitude here. All right, then the rest is just the implementation of the formula here. Okay, so what I'll do is df of distance is equal to HAVERSINE NP. HAVERSINE NP is this. All right, so I'm just passing the parameter. So what I need to pass is the pickup longitude, right? So I'll just say pickup longitude. All right, and here is the pickup latitude. And I need to pass in the drop off longitude, right? Drop off longitude and df of so let me just run this. So if I look into what is there, we'll have the distance, distance traveled in the taxi, but you'll get the distance between 2 points. Using these values, we have calculated the distance between 2 points. All right. So the next thing is we'll use another visualization package. We already used Matplotlib and Folium. right? We'll use another, it's an important visualization package called Seaborn. So what I'll do is I'll import CNS, all right? So I'm just setting the figure size for whatever I need, right? And so this plot is the distribution plot. So distance, all right? Give me like bins equals 1000, color equals, and give me a green one. KD here, KD is a kernel density estimation. So what it does is it plots the Gaussian kernel density estimation. If you don't know what Gaussian curve is, it's the bell curve, all right? And I'll just say false. I don't need that. So let's say, plot it. Yeah. So now we have the distribution, right? So you have it here. So you can add the title xlim ylim. You can do that, but for this I'll just leave it here. So what we can do is we can get some stats about the distance column, right? What I'll do is I'll say distance and how to get it. So we just use that describe. So yeah, so describe shows us that the minimum distance traveled is there is 0 also. So we don't need that. We that doesn't make sense in our data frame. So what we'll do is we'll just again drop that using .log df of distance greater than 0, right? So yeah, now the distance has been dropped, and then the next thing what I think we have we have everything. Yeah, we have everything in place, right? We can directly dive into some model training. So what we'll do is we'll directly start into building. We'll directly start with building the model. But before building the model, so let me just show you. If you look into this, the key and the pickup date time doesn't add anything helpful for our model, right? Because we have already stripped everything from pickup date time and created another another columns. So what we can do is we can just drop it. We'll just delete it. There are various ways to do it. You can do whichever way you want. Pickup date time. So we are doing this because it doesn't add any value to the column, to the model we are building. So we'll just delete it. All right. Now what we'll do is I'll start with from sklearn dot model dot model selection. All right. Import train test split. So what I'm doing here is scikit-learn is one of the important packages in data science. So from scikit-learn, I'm importing something called train test split. So what I'll do is I'll pass in our train.csv and ask it to split it into train and test so that we can validate our model. All right. So I'll just import it. So what I'll do is I need to tell what is the target variable, right? So our target variable is fair amount, and x is dot drop columns equals fair amount, right? Train comma x test comma white. I'll explain what this is, right? And what's train, test, split, x, y. Give me the test size of 0.3 and random state. Okay. So what I'm doing here is, so y is our target variable. So what is our target variable? So I'm saying fair amount is a target variable. So next thing what I'm doing is I'm dropping the fair amount from our um, from the data frame and assigning it to x. All right, and after doing that, so what I'm doing here is I'm calling train test split, which is from here, and assigning it to x train x test and y train y test. So what the so to inside the train test split, what I'm passing is the x, which we have here, and y, and what I'm saying is test set is equal to 0.3. When I say test set is equal to 0.3, let's say there were 100 rows, and when I say test split, test size equals 0.3, it's 30% of it, will be the test size. That is, 30 will be the test size, and 70 will be the train size. That's what I'm saying here. And when I say random state equals 50, so for every 50 rows, um, for every 50 rows, it keeps it changing. All right. For first 50 rows, 30% will go to train, and the rest will go. The 30% will go to test, and the rest will go to train, and it keeps mixing, and we'll get a good mixture of of the data. All right. So what we'll do here is I'll run this. Okay, now we have everything in place, so we'll directly start by building our linear regression model. All right. So here, what I'm doing is, let's say scalar dot linear model import linear. Linear regression is a regular y is equal to mx plus c. That's what this will implement here. To start with, I'll create an object of linear regression. Then I'll say all right, but comma y train, and so here I have a x train here, I have y train here, and for every x train we have the corresponding values of the fair amount or target variable, and we are training it here. The next thing is, after training, we need to predict it. So I'll just assign y to y pred lr dot predict x test. All right. So we have all the predictions here. We can sit and go through everything, saying which um, if the prediction made was right or wrong, and to give you a metric of how it is done, how it is performed. All right. So what we'll do is we'll say metric import mean error. All right. So this is where skew. Okay, it's just a spelling mistake. All right. So have it here, and I'll say RMSE of percentage F. So what I'm saying here is, give me just up to 3 decimal points, and that will be mean squared error. All right, of y test. Y test is the actual values of our actual values of the data set, and ypred is the predicted values. And now what I'm doing is I'm square rooting. So mean squared error, I'm just square rooting the mean square error to get our RMSE value. So let's see how it has. Okay, invalid syntax. Okay. File. Okay, again the spelling. That's the spelling mistake. Oh, the most of the program will be just like this. And invalid syntax is it. We'll just Google it. RMSE Python, right? Okay, so we can just do this. So our y actual will be our y test, and y predicted will be our y pred, right? So we'll see. Okay, okay. Let's print our. Okay. Oh well. So this performed quite well. Just a simple linear regression model performing with the RMSE value of 5.21, and with the basic estimation in the problem statement, it was said it was between $5 to $8. So just a simple regression model, has given us almost 5.25. That's a good good model there. So next, what I'll do is we'll construct a random forest. All right. So just time it. Okay, from sklearn some world input. Sorry, import random forest. I don't want the classifier. We are predicting, so we need a regressor, right? Then I'll create an object of random forest regressor. All right, and I'll say max depth equals 2. I'll get into what all these are. Random state, I'll say, I'll just give it 0, and estimators equals 100. And I'll put x train, y train, and we have y pred is rf dot yield predict using x test. Okay. So in the meantime, it runs. So I'll explain a few things about decision trees so that you'll get a better understanding about what random forest is now. Okay, so you can think about decision trees as simple flow chart. All right, it's a flow chart like tree structure where each node denotes or represents a test on an attribute, denotes an attribute or a test on an attribute, and each branch represents an outcome of the test, and each leaf node holds a class label. So today we'll to construct a tree, there are a lot of algorithms which you can follow, and today we'll dive into something called ID3. So to explain what how ID3 works for the tree construction, so let's take a small example here. So these are the columns: outlook, temperature, humidity, and windy. And with these given values, you'll go out to play or not. So that's what you need to predict. So there are 14 such samples, and how you do it is you calculate something called entropy. So entropy is just the measure of randomness. Okay. Um, so this is the formula. So if you don't get it, don't worry about it. So there are 14 instances here, right? There are 14 rows here, and out of 14 rows, 9 are classified as yes, and 5 are classified as no, if you count it. So no, now what we'll do is we'll calculate something called POS, which how many are yes? That is 9 are yes out of 14, and log 2 we will multiply with log 2 of 9 by 14, that is 9 arrays out of 14. So you'll get 0.41. Again, P of no is out of 14 there are 5 no's, and we'll calculate we'll multiply it with log of 5. What we are doing is we are just plugging the values here. All right. So you'll get 0.53, and we have the summation here, so we'll just add these two. You'll get 0.94. So what it states is out of the entropy of the whole data set is 0.94. All right. So what we'll do next is, after calculating the entropy for the whole data set, we'll calculate entropy for each variable. So what is the entropy when the outlook is sunny? All right. So to give you an understanding, there are how many sunny here? Outlook 1, 2, and 3, 4, 5. There are 5 sunny variables here, and out of which this is no, this is no, and this is no, this is yes, and this is yes. Okay. There are 5 sunny instances in the outlook, and out of which 3 are no and 2 are yes. All right. So that's what we are doing here. We're just plugging in the values here. That's what the same thing what I hear is what we are doing. So 2 by 5, 2 are yes out of 5, log of 2 of 5, minus 3 are no out of 5, log of 3 of 5. So we get 0.971. And again, for every possible variable, so outcome. So we'll take. We'll keep repeating it, and you'll get some answer there. So after doing that, what you will do is we'll take the average entropy, something called average entropy information. So what we'll do here is there are 5 sunny out of 14, right? And there are into the entropy which you calculated plus 4 4 overcast out of 14 into the entropy you calculated. There are 5 rainy out of 14 into the entropy you calculated. All right. So this gives you the entropy information about a value of 0.693. And the next thing what you do is you calculate something called gain. So gain is the total entropy of the data set minus the entropy information of the particular variable. So total entropy, we calculated it here as 0.94, and here it is for this particular variable, entropy information is 0.693. So you just subtract it and you get 0.247. All right. So you do it for every other variable, and you just pick the highest, whichever gives you the highest as the root node. All right. That's how that's how from from complete randomness you got the root node. All right. So that's how you get the root node. So what you do is you repeat the same thing for the subtrees, and you'll get something, the final tree, something like this. All right. This is how our decision tree is constructed. Why I explained you this is all these random forest and XgBoost, like GBM, everything. These are just the ensemble of these decision trees. All right. So ensemble learning is a method of technique that combines the predictions from multiple machine learning algorithms together to make more accurate predictions. So what does this mean is, so you need to understand one thing here is our decision trees are weak learners. All right. So you bring all the weak learners together to build a better accurate to build a stronger model which gives you a better accuracy. All right. So it's like apes together strong. All right. So there are 2 types of ensemble learning. There is bagging and there is boosting. I won't go deep into it, but just to give you an understanding here, bagging often considers homogeneous weak learners. So what bagging does is they learn independently and in parallel, and they combine. The output will be an average of all the outputs. All right, and with the boosting, what they do is they learn sequentially and in adaptive way, and they combine in some a deterministic strategy. So the example of bagging is random forest, which we ran right now, and boosting is like GBM, XgBoost, and CatBoost. All right. So we'll run one among these today right now. So this is a basic understanding of how this tree, how the tree is constructed, and how what is ensemble learning, just and what are the types of ensemble learning. So okay, this is still running. It will take some time, but in the meantime, what we'll do is we'll construct here. The other thing is we'll we'll do something. We'll do the like GBM. I'll show you one example of the boosting method also, how to do it. So you import like GBM as all right, and you define the parameters as your learning rate is your alpha of the gradient descent, and what's the application we are using it for. We are using it for regression, right? And what's the you can define whatever the maximum depth you want. I'll just say 3, because the more number you put, it takes a lot of time. And what are the number of 100? All right. The and metric here is we need the RMSE. All right. Okay. Oh, this okay. We're done, right? Okay. This took around 9 minutes. So what we'll do is, in the meantime, we'll just calculate the RMSE for this as well and see how it has performed. All right. So this is almost the same, but I think the simple linear regression performed better than random forest regression. All right. Just for your understanding, the if you are doing some predictive analysis, all right, then the boosting method gives you a better result than the bagging method, that is random forest here. So let's say if like JVM performs better than random forest, so I'll say gb.dataset, then I'll just train and y train, right? And let's just gb.train. We are passing the parameters here, which we defined here. We'll pass that, and other thing what we need to do is, that equals train set, which we defined here. So we'll just run that. Now it's training in the cell, and is equal to lb dot predict. So it just took 15.8 seconds. Okay, now it has predicted also. All the syntaxes are pretty self-explanatory. Um, you know, I just dot train, trains the model, and you're passing the parameters here, params, and it trains it as the object you are creating together with X train and Y train. And then what you're doing is ELB is this one. After training, that's the model. So model dot predict, and you want to test the X test, and you have Y pred here. So let's see how it has performed. We'll just copy paste this. Oh, so it's 3.65. Like, that's a really good score. I think we have achieved what was required. So they said the RMSE value is between $5 to $8. We need to do better than that. So uh, I think we have done better than. Yes, we have done better than $5 to $8 RMSE value. So you can think about it as this random forest took uh, for depth 2, and so here n estimators is saying give me 100 for 100 trees for random forest. All right, so that's what I'm saying here. uh, so for depth 2 and n estimators 100, it took almost 10 minutes, and just here for depth 3 and leaves 100, so it took just like 15.8 seconds. So I think as we postulated a hypothesis saying that uh, the a boosting method performs better in predictive analysis than a bagging method. I think it holds good because the RMSE here is 5.21 and the RMSE here is 3.65. It certainly uh, did a really good job. Um, so I think we have achieved whatever we were set out to do today, and I hope you learned a lot in this past 1 hour. How of how to um, how to build models, and how to visualize them, and some of the syntaxes also. And yeah, so before I end the session today, so for everyone who are thinking about starting your career in data science, or if you have some experience and you want to jump to data science field, uh, when in 2010 the cats versus dogs classification problem was done with something like 60 million parameters. That was like the huge break from machine learning being breaking from research to production. All right, so and a lot of exciting things happened this decade, and the recent major improvement in the machine learning field is the OpenAI's GPT-3. So it has around 175 billion parameters. All right. So last decade we started with 60 million, and this decade we have reached to 175 billion. So that's if you look at it, that's like 3,000 times more. All right. So if you just predict for the next decade, if you for easier computation, is say if it increases by 3,000 times in the next decade also, that's 525 trillion parameters of the data is training on 525 trillion parameters. To give you an understanding, a human brain has 100 trillion parameters. All right, so probably this decade will certainly be there will be a lot of exciting stuff. And if you guys are thinking about jumping into data science or starting in your career in data science, this decade holds a lot of exciting stuff for you guys. And thank you for attending today's webinar, and I really hope you learned some you really learned some stuff here. Thank you.